My name is Kainton, the Tech Pro, and today we are going to be talking about linear regression in Python and R. And this is something very important because if you look at this diagram I made up, you can see that machine learning is broken down into different sections. So one good way to start learning machine learning and data science is to start with one of these, either classification or regression. And I figure out that regression is a very good way to start. So if you start from regression, you can move to classification and move upwards to the other side of it. And if you start in the wrong way, most likely it will be difficult for you. So regression is a very easy way to start, and that is why I've chosen to start with regression. This is for beginners. If you don't have knowledge of data science or programming, you will be learning as we work together. So feel free to follow along, make sure you are consistent, and if you have any challenges, let me know. Also, to not miss an update, subscribe to my channel by clicking on the subscribe button below so that you kind of encourage me to keep making these lessons. And as you watch you follow my lessons, you find out that it's very easy and you can actually work with me. We are going to be using Jupyter Notebook. I'm going to just open Jupyter Notebook as you can see. So if you've installed Jupyter Notebook, and that is fine. If you've not installed it, please install it right now. It is free. You can get it from the website. Again, I also have my Blackboard. I will be writing some things along the line. The reason is because there may be some explanations that need to be made. I'm going to write down. So let's get started. Also, if you're not subscribed, please, you can just subscribe. That is fine. So the first thing I'm going to do is to go to the presentation. Let's take some background of regression, and then we go to look at the data set and we'll be able to do regression and be able to make some inference from our data set. So we're going to be looking at background of regression problem. What really is the goal of regression? And then we are going to look at the advertising data set. We are now going to use regression, apply it to machine learning, and see how we can advise a company or an organization to either increase or reduce the amount they spend on ads they place on radio, TV, or newspaper. We'll see how the budget spent in TV, radio, and newspaper adverts directly affect the sales of the company. And we see how we can also extract features into variables. We see how we can plot this data set and see how the variables interact and be able to understand the data. Then we also estimate the function. What is the function that relates the input to the output? What is the function, the formula, if you will, that relates the budget on ads to the output, which is sales or the profit? So what function is this? And also what questions are answered by the regression? We are going to talk about simple linear regression because there we also have polynomial regression and we have multiple regression, which we are going to continue with after this particular section. Then we see summary of regression. When you perform a regression, you have a summary of data that is provided. How do we interpret this data? We also talk about pairwise plot and scatter matrix. And then we move on to some theoretical things if you want to go a little further. So the first thing I'm going to do, I'm going to move to the next slide. So for now, suppose we are statistical consultants and we are hired to provide advice on how to improve sales on a particular product. So this company actually places adverts, let's say this is in thousands of dollars. It's a very big company. So they spend $230,000 on adverts on TV. They spend $37,000 on adverts on radio, and they spend $69,200 for newspaper adverts in that year. And the sales increased by 22.1%. So assume that this sales is in percentage, okay? So this is the background of regression problem. How do we advise them on the amount they will spend on radio, TV, and newspaper? So this is background, and now the goal is that it's not possible for them to just keep increasing the budget on adverts because it might actually come to a point and it's counterproductive. And on the other hand, they can control the advertising expenditure in each of the three media separately. Therefore, if we determine that there is some association between the advertising for each of these media and sales, we can now tell our client to adjust the budget and then lead to maximum increase in sales or profit. So our goal is to develop a model that can be used to predict the sales based on the 3 media budgets. Now I'm going to open the dataset, this advertising dataset. If you look at the description box of this video, you can find this dataset, link to this dataset, download it, and then put it in your Drive D or in some folder in your computer, and then you'll be able to open and follow. So at this point, it's coming for us to now do the practical. At this point, I'm going to open new Jupyter Notebook. Just go to New and choose Python 3. If you choose Python 3, and we are going to be using pandas. Pandas is used to import data and to manipulate data. So I'm going to write a comment that says working, or let me just write regression for machine learning and data science. So the first thing we want to do is to import pandas. Import pandas as PD. Now there are other modules we need to import, for instance, module for plotting and module for doing some calculations. For now, let's keep it simple by just importing pandas. And then let's import this data set into the workspace so that we can see this data set as it is. So to import this data set into our workspace, you will simply say adds data. Now adds data is a variable. If you import this data, we want to assign it to a variable, and that variable is I'm going to call it adds data. So you are going to say PD. So PD stands for pandas dot read underscore CSV. So this is a function used to read data, and then specify open and close single quotes and specify the location of the data. I have it in a folder called data and others, advertising.csv. So hopefully this will be fine. So I've imported this data. How do I view this data? To view this data, I can actually just write adds data. Now, anything you want to do, if you want to run a particular line, just click on run here, as you can see. And you can see this adds data right there. Now, it's occupying so much space, so I'm going to also just say view the first 5 rows of this data by saying adds data dot head. I think that is a way to view the first 5 rows of this data, right? Now you can see that there is one column there called unnamed 0. I don't really know what it is. So what I'm going to do, I'm going to remove that column, and I'm going to show you how to remove this very column right now. So to remove this column, you are going to just say you need to overwrite this very variable. We call it a data frame with a new one. So add data. We are going to only select the particular columns we want. So I'm going to say adds data, and I'm going to open 2 square brackets, and I'm going to just choose TV. Also choose radio, choose newspaper, and finally I choose sales. So at this point I have the data extracted, and I actually what happened? It's not callable. So adds data. So you say data frame is not callable. So I think I should take out one of these. So let's see. Okay, so newspaper. So we have a title. So I have this right here. Okay, so I've extracted this data by removing the unnamed column. I don't know where it came from. So if I run again, adds data.head, now you can easily follow this because I'm making it very easy. Now if I run it, you can see that that column is no longer there. So let's go back to the presentation. Let's see what we are going to do. Okay, we have another way to remove the unneeded column by using this iLock, but I want to keep it simple. Now you want to see the summary of this data set. You want to see the summary of this data set. You can just say adds data.describe. I think adds data.describe is going to give you a summary of this data set. So it's telling us for TV we have 200 records. We have the mean, we have the standard deviation, we have the minimum of that column, we have the maximum, and we have all these other values provided, and so on for all the other rows, all the other columns of data. All right, so that's about the describe. Let's move on now. We need to extract the features into variables. So what we are saying is that we need to put each of these columns into its own variable. So what we are saying is we are going to extract all the column for TV, the column for radio, and the column for adverts. So I'm going to just read what I have in my presentation. In this section, the advertising budget are input variables, and sales is the output variable. Now, the input variables are typically denoted by the symbol X with subscript to distinguish them. So X1 for TV, X2 for radio, and X3 for newspaper. The inputs go by different names. You can call it predictor variables, or independent variables, or features, or just variables. So for me, I like calling it the features. The output variable in this case is just sales, is only one of them, and it's called the response variable or the dependent variable. Now, these terms are very important. In machine learning and data science, you should be able to understand and use the correct terms. In this case, we only have one Y, and we just have Y. But for TV, radio, and advert, it's X1, X2, and X3. So how do we extract these columns into these variables that we have here? That is what we are going to do right now. So the first thing I'm going to do, I'm going to just say X1. So to do that, you simply say adds data. I think you are going to say something like, so you have two square brackets and just say TV. So I'm going to now reference my presentation. So okay, you use only one opening bracket. So so let me just check if it works. Okay, so we have the typo here. So let's try. Okay, so I'm going to just check just to be sure by running X1. Okay, it worked perfectly. All right. So let me extract also for radio and newspaper. So XO is equal to. Now I recommend that as I do this, you also follow along in your computer, because in machine learning and data science, it's better to follow, be doing it yourself. The more you do it, the more proficient you become. So adds data, we have radio, but there is some mix-up because it seems that I use sometimes X2 is not defined, so you can see. So actually I need to use two square brackets there. So if I run it now, everything should be fine. So you can see. All right. So let me take out this, and let's assign for X3 equal to adds data. Let me also say newspaper. So at this point, I'm going to also try to check if everything is fine. So let's run. Everything is okay. Good. Again, I'm going to just maybe use a single square brackets at this point. All right. Okay. So let me just assign the last one, which is y is equal to adds data, and here is going to be sales. All right, so this is what we've done, and everything is perfectly okay. The next thing we want to do, let's move on to the next slide. Let's try to plot this data set to actually see how it looks. Now, if you look at this plot, it looks complicated, but I'm going to just plot it in a simple way without having to do all of this. So let me show you how to plot in very easy way. So actually, you can say plot x1 against y. It's as simple as that. But before you do that, you'll need to import matplotlib.pyplot. So let me just insert a cell below, and I'm going to say import matplotlib.pyplot. This is a module used for plotting in Python. So if I run it and I run the next one, you can see. So actually, let's say as plt. So to plot, you actually need to use the alias plt.plot. So so sorry, let me see. So this is basically how to plot. You can see it's giving us some kind of strange plot. So it's easier for us to use a scatter plot. So I'm going to just use a scatter plot, and you can see it makes more sense now. This is a scatter plot. I want to plot the three of them side by side. Again, you can just plot the three of them by just plt.scatter x to y, okay? And then plt.scatter x3y, okay? Now the three of them, I want them side by side. I'm going to say plt.show. Now there's something called subplot. So I want to plot this first one in column 1, column 2, column 3. Like you have in my presentation right here, you have this is column 1, column 2, column 3. So to do that, let me just show you. You are going to say for the first one, you are going to say plt.subplot. So the grid for this plot is 1 row and 3 columns. So that is what we are going to say, 1 row by 3 columns, and we are plotting it in the first position. Yeah. So in the case of the second one, plt.subplots is the same 1 row by 3 columns, but now is a position 2. So I'm going to put position 2. And then the last one is the same plt.subplot. It's also 1 row by 3 columns, but in position 3, right? So if I run, you can see we have subplot. So we have a typo here. So it's subplot, not subplot. Okay, so let's see. So you can see the three of them have actually plotted here. Now I'm not going to worry so much about making it bigger or smaller to just keep it simple. But I'm going to actually change the color. So I'm going to say color of the first one is equal to green, and the color for the second one is equal to red. Okay, the last one can just remain blue. Okay, so you can see this is the scatter plot for the three of them. Okay, so now I would like to recommend you try to do what we have in my presentation. Try to use a fig size. Again, maybe I'll just use it. So it's actually plt.figure, and you specify the fig size so that it can actually distribute the plot across. plt.figure, and then you specify fig size equal to, did I say 10/5 or 10/6? So let's see. Okay, so it actually spaced it out a little, which makes some sense. But I can actually increase this to 6 and see how it goes. So for you, so I missed out this, so let me run it again. So for you, I'll recommend you take some time to change up things a bit to see how it looks. Now let's go back to our presentation. Remember, we are talking about regression, and for now, what we are doing is to try to understand our data set. The next thing we are going to do is to try to estimate the function that relates the budget for TV to the sales. We also try to estimate the function that relates the budget for radio to sales, and the function that relates the budget for newspaper to sales. That function is f of x, or f of x1. Now, how do we estimate this function? So suppose we observe the quantitative variable y, and p different predictors, that is 3 predictors, x1, x2, up all the way to xp, in this case x1 to x3, we assume that there is a function that relates the two, y is equal to f of x and plus some error, okay? And we assume that we have observed n different data points because we need a finite number of data points. In this case, we have 200 data points in our data set. These observations are called training data. This is for you to know about the terminologies. These observations are called the training data because they are provided for you and you are given equivalent sales that came out from there. So you are kind of given a preview of how the market performs so that you'll be able to predict what is going to happen with new budgets that's going to be made. How do we estimate F? That is a question that we are going to be answering right now. Now, I'm not going to read this. I'm not going to read it. I'm going to just go to the blackboard and just show you how to do it. So to estimate F, we are going to say, first in linear regression, we are making an assumption that there's a linear relationship between the predictor variable and the response variable. So in case of newspaper, we'll have something like F. Sorry, let me use a different, sorry, I'm going to put back this. I'm going to use some other thing. So we are saying that in case of newspaper, we are saying that function of x1 is equal to beta 0 plus beta 1 x1. Right? So this is an assumption that we have to make. Now this we are talking about only one variable for the TV, and in this case, if I'm writing it using the variables, so y or the sales will be function of the TV budget is going to be equal to beta 0 plus beta 1 TV. Okay, so the function that relates the sales, it will be beta 0 plus beta 1 times the budget for TV. Okay, so the question is, how do we now get beta 0 and beta 1? That is the question, beta 0 and beta 1. So this is called the parameters of regression. It's also called regression parameters or regression coefficients. Most times, the problem to solve in regression is to determine or estimate the regression coefficients. All right, I'm going to advance my presentation to display. Now I'm not going to do this because I want to actually do the regression and we determine the regression coefficient. We are going to fix this regression coefficients into that function and then we have the function that relates the sales to the budget. So now there are two ways to do regression in Python. I'm going to teach you these two ways. One of them is by using sklearn.linear models, and that is what we are going to use at this point. So I'm going to come back to Jupyter Notebook, and I'm going to, at this point, I'm going to shrink it so that you can see what I'm doing. So I'm going to just shift this a little bit to this place, okay? So hopefully you can see everything. So I'm going to say, first I'm going to put a comment that says, now perform linear regression, okay? So I'm going to shift this one a bit. All right, so to perform linear regression, we are going to import the module called linear regression from sklearn.linear models. So I'm going to say from sklearn.linear_models import linear regression. So I'm going to also run it to make sure there is no error there, okay? sklearn.linear models from sklearn.linear models imports, let's see, I think linear regression. No module named sklearn.linear models. Is that a joke? sklearn.linear underscore models. From sklearn dot linear models, import, let's see, is it linear model or linear model? So it's actually sklearn.linear model. So one thing that we do called pre-processing, I discussed it in a different lesson, is to actually pre-process the data to make the data fit for linear regression. I'm not going to spend time to explain it, but to do that, you simply say x1 is equal to x1 dot values dot reshape, and it reshape between -1 -1 and 1. Okay, again, I'm going to run to make sure there's no error. So the next thing we want to do is to create a linear regression object. So let's call this linear regression object linMod. You can give it any name you want, it doesn't matter. Is going to be equal to linear regression. Okay. So now this object is what we are going to use to perform linear regression at this point. So the next thing we are going to do is to now say linMod. I also like to run the cell to make sure I'm not having any error. linMod.fits, and I'm going to use x1. So fits x1 to y. So fit the TV adverts to the cells, corresponding cells. I'm also going to run it at this point. Okay, perfectly well. Now I'm going to determine the regression coefficient, and the regression coefficient is going to be so basically you can say linMod dot coef is going to give us the regression coefficient. I'm going to run it to print it, and the next one is print linMod dot intercept. I'm also going to run it. All right, now we have the coefficient and the intercept corresponding to beta 0 and beta 1. These two items or variables are called regression coefficients. Make no mistake about it. Now let's formulate the equation of this regression line. After that, our work is not done. We want to fit a regression line through this data set and see how the regression line is going to be. The regression line we are going to feed through the data set is called least squares regression line. This is theoretical. I'm going to explain it later in a different lesson. For now, I'm going to go to my blackboard or whiteboard, as the case may be, and let's now form this equation. Now, from the model we created in Python, we have that beta 0. This beta 0 is the coefficient. Beta 0, sorry, is the intercept, and beta 1 is the coefficient. So beta 0 is equal to, as an intercept, 7.03, and beta 1 is equal to 0.047. Okay, so at this point we can write a beautiful function that relates TV adverts budget and the sales. So I'm going to just say f of x1 equals, so we have 7.03 plus 0.047 x1. This is the function that relates the two, TV sales and the adverts. So what it means is that if you actually remove this very term and you don't place any adverts, you can tell the company if they fail to place any advert on TV, they will also make some profit, but only 7.03 units, right? But if they place adverts on TV, they are going to make 7.03 in addition to 0.047 units of the budget they place on TV. So what we are saying is that the sales is increasing by 0.047 units each time. So you can call it 4.7% increase in sales is achieved for every 1 unit of budget spent on TV. I think this makes sense, and I think I'll say spend some time to understand it and see how it works and also appreciate how it works. Now that we have determined the function relating it, let's now try to fit a regression line through the dataset. But wait a minute, I mentioned that I'm going to teach you two methods of performing linear regression. Now there is the second method using the stats model. Now since I want to keep this simple and short, I'm going to stop here and then I'm going to be switching into another video or into another lesson as part 2. And then we continue to see how we can do linear regression using a more powerful module called the stats model. And then we also see how we can fit a regression line through this dataset and be able to understand how these variables interact with the output. So I'm going to stop at this point, and I'm going to recommend you like my video also. If you learned something from this lesson, please subscribe to my channel and leave me a comment to let me know how you feel. I remain Kindton the Genius, and my intention or my goal or objective is to teach you how to be a data scientist, is to help as many as possible become data scientists and machine learning experts as well as programmers, because this is knowledge I've acquired over the years. Again, I thank you for viewing, and we see you in the next class.